information. So regular old water ski boats, those buffering distances have been established for freshwater lakes all across the United States historically from anywhere to 100 to 200 feet. Think back to the 1950s, you know, you had a water ski boat, a Crestliner. 100 feet or so from shore was what you typically see. Sometimes that's statutorily defined, sometimes not, but 1 to 200 feet. To minimize risk and damage to kids on the shore, the boats tied up to the dock, etc. The introduction of wakeboard boats, particularly in surf mode as we've described it, has produced wave features that are, in red, simply incompatible with existing standoff distances and the statutes that have been established for the traditional water ski and cruising boats. They just are. It's a different animal. They produce waves that are smaller, less surface energy, and shorter attenuation distances. The water ski boats, the pontoon boats, even the jet ski. Studies have identified this concern with recommendations for buffering distances, new ones, now anywhere from 500 to 1,000 feet, depending upon the size of the lake and the features of the shoreline. Features of the shoreline. Some lakes have a shoreline where the slope under the water that you do not see is extreme, and it goes way down like this. That affects that unseen energy as it comes up. Other lakes have got a gradually sloping bottom, topography. That too affects that energy. So again, seen energy and unseen energy impacts. I'm going to keep harping on that as we move along. Go back to that slide one more time. That, by the way, is an image of the cell phone app that can be purchased that tells a boater in a state where they're not allowed to be anywhere except in a safe wake zone where they are. The study groups, the engineering groups, the science-based groups, university-based, that have done these studies include Jeff Marr and his team, University of Minnesota, St. Anthony Lab. Our group, Terra Vigilis, the University of Colorado, out in Idaho, and then finally an engineering group in Georgia, Water Engineering Consultants. Those are the groups that are producing the data, which is well organized so you can count on the integrity of the information. Okay, when you see one of these go by, what you see is a big wave at the back. That obviously has some energy to it. We've already explained to you that the surface energy that you see, depending upon the height of the wave, can be a multiple in terms of energy production. But there are 3 other features to what's going on in the production of energy from these vessels. There's a bow wave, so that V hull is displacing water ahead of it. There's a bow wave impact. There's a stern wave impact. The stern is dragging through the water, producing a displacement energy impact. An interaction between the 2 waves called a transverse wave. And then finally, fourth, the propeller downwash energy source. That downwash, we have any aviators in here? You know what a microburst is, right? So a microburst is comes out of the bottom of a bad cloud at about 100 or so or more, 200 miles per hour, straight down in a column. When it hits the ground, it spins out to the sides. If you fly through it, it's very bad. It's a paperwork drill. These propellers are essentially doing the same thing. They're producing a microburst, a push of energy at their angle, which is about like this, right? So 45, 50 degrees, right towards the bottom. So 4 sources of energy come from a wakeboard boat in surf mode. Bow wave, stern wave, transverse wave, and the propeller downwash, sometimes called a slipstream.
So why are we telling you this? Because it's the things that are unseen. When you see some of the videos, you're going to see the effects of each of these in what's moving on the bottom. Plants, sediment, streamers from water movement. And the each have kind of different characteristics in terms of what's being affected underwater.
Next slide, please. Now we're going to talk about things that you don't see, that are a little more subtle. We started out looking at surface waves 7 or 8 years ago. And then we discovered, in fact, one of the things that's interesting, little anecdote, I'm a flight instructor. So I would fly flight students out from Waukesha Airport towards the lakes area. That was one of our practice areas for maneuvers in the sky, right? So I'd fly over North Lake, say hi to my friends, waggle the wings, maybe 2,000 or 3,000 feet above the surface. I'm flying over North Lake one day, and I see this very large cloud in the water coming from the little lake on North Lake. There's 2 lakes that adjoin one another. Moving towards the big lake, there's a reef between the 2 lakes. It hits the reef and pops over the top of the reef and settles on the bottom other side. That doesn't look right. That's of concern. That's not necessarily something you'd see except from the air. We chatted about that phenomena with the scientists over at the Southeast Regional Planning Commission. And when we first showed, then we got video with drones, and they went, oh my goodness, this changes the ball game, guys. We were unaware. This is producing plumes that move and are moving in directions based on obstructions that they hit underneath the water. So we're going to talk a little bit now about those subsurface impacts that are not so easily seen. Our studies have, can you back up just one, I'm sorry. Subsurface impacts. Unseen energy related to these large waves. Significant impacts to subsurface structures, to lake bottom integrity, so the sediment, the lake bed. Release of sediment, which changes the water chemistry. In addition, the subsurface energy impacts shoreline structures, the bottom composition that secures a seawall. If there's constant roiling, it loosens up the body, the bottom composition that holds the seawall in place. The seawall's loosened. The water environment consulting groups do a lot of work with big reservoirs that are held in place with large concrete abutments, and they're concerned about the impact of those seawalls. That's where that information comes from. In shallow areas, significant impacts to fish habitat, waterfowl nesting, and aquatic plant life. We've demonstrated penetration depths beyond 25 feet. 25 feet. Let me repeat that. 25 feet. Kinetic energy on the bottom. Next slide. So on your lake, we set up a testing condition, and we ran wakeboard boats over a predetermined course, and we measured their bottom impacts at startup. So they're prone, and they floor the engine and take off just like they do when they start up with a skier behind them. And then we also did testing with passes in a wakeboard surf mode configuration. So now they're at 10 miles an hour and at this big high bow angle. And what you're going to see now is the impact on the bottom. The lake bed has a lot to do with what you see. If it's a lake bed area where there's no plants and it's soft and mucky, all kinds of stuff stirs up. If it's a lake bed area where it's marl and sandy, you don't see much, maybe a little bit of disturbance. If there's plant life, depends on the kind of plant life. If it's plant life that has root structures that don't go into the bottom, it pulls them up out. You have a combination on this lake in these sensitive areas of coontail, pondweed, and cara. So that is at 15 feet, impacts that are not demonstrated with those other vessels. How come? Because they produce a different wave. The energy is moving behind the boat horizontally. They don't have a great big V-hull. They're on plane. They're not producing a big displacement wave. This is a video from the study at Lake Minnetonka, done by the University of Minnesota people. What you're going to see is a bottom that didn't have a lot of plant life, and it was soft, sediment, mucky. You'll see what the energy does to that kind of a lake bed in just a moment. Boat's going right across the top of the measuring equipment. Here comes the boat. That's 14 feet of water. 14 feet of water.
So when I was describing those, or Tim was describing these different types of waves that are being affected from the vessel, bow wave, where it's pushing forward and down. Stern wave, you got this big hole in the water behind the boat. It's pulling or lifting back up. And then the transverse waves, because you're creating this pumping action, I'll call it, you're seeing the actually going back and forth. These transverse waves are literally for minutes scrubbing or pushing the water back and forth across the bottom. And you saw the prop wash when the prop wash was actually propagating down the bottom. So you see elements of all of those show up in these videos.
Unseen, but certainly powerful evidence. Next slide, please. While we're switching over, a good question ought to be in your mind is, well, goodness, if that's happening to a lake bed and all that sediment is being roiled up, wouldn't there be concern for what's in the sediment now being displaced into the water column? And the answer is absolutely yes. It wasn't within the scope of the study we were retained to do on Lake Beulah, but in other lakes, they've asked us to look at the chemistry impact. And of course, what you'd expect, there's an increase in phosphorus, which promotes weed growth, algal blooms, et cetera, among the other things that are in the bottoms of Wisconsin lakes. We'll talk about that in a little bit. Okay, now we're going to look at a wakeboard boat on Lake Beulah in 25 feet of water.
So the primary thing we can see here, obviously the water's a bit cloudier because it's sediment at the bottom. There's not as much aquatic plants. There's a brick holding our camera tripod at the bottom, and sediment is actually being moved by some of those bow, stern, and transverse waves, where sediment is actually being put on top of that brick. When we first had it down at the bottom, it was clear. So may not be as dramatic as you would expect, but we're still seeing sediment movement, which is affecting what potentially could be going into the water column and affecting the chemistry.
Wakeboard boats in surf mode operations were introduced about 15 years ago. We started looking at this when people got excited on North Lake about 8 or 9 years ago. It's only in the last 5 years that a number of research groups are starting to look at these unseen bottom impacts, and we're discovering more and more as we look. So the wave physics associated with large displacement wave actions have demonstrated to produce in the near shore lake bottom a scrubbing effect. The depth and shoreline slope has been demonstrated as a variable in that regard. So as I spoke about before, if it's an extreme slope in the way God made your lake, it has a different impact than a gradually sloping impact. I lived on North Lake for 40 years. I had a home on the Little Lake near Charles. We're buddies. And when wakeboard boats were introduced there, about 2015 or so, I would go down to the shoreline. North Lake's a pristine lake, it's like Beulah. And there'd be muck out about 10 feet laying on the bottom, and it's very shallow. North Lake has got a shelf. It's only about 3 feet deep, and then it drops off into a bowl. I go down once a week and spend 4 hours digging all the muck up, putting it in a wheelbarrow. By the time I got a month through the summer and there was mounds of this stuff that stunk, I got annoyed because I knew where it was coming from. It's coming from this. The unseen energy is scrubbing the bottom. So again, the takeaway is obvious energy impacts on the surface, unseen, not so obvious, but real impacts underneath. We're doing studies where we have controlled designs, so we're careful about the things we say, and when we do test condition passes, they might do it 2 or 3 times. That's not all day long, 5 days a week. The DNR did a study on Lake Beulah looking at critical habitat areas. Critical habitat areas are defined as an area where wildlife, lake characteristics, chemistry, etc. could be harmed because it's in a sensitive area. The deep orange areas that are designated on this image, here, here, and here in particular, are where some of the impacts that we're describing are occurring on Lake Beulah. Just consider it. Next slide. This is imagery. I don't think we have this as video, but it's a good example of what we're talking about. This is on Lake Warrabog out in Connecticut, 800-acre lake, similar in some ways to Lake Beulah. Deep, except where the inlet for the lake is fed from a stream. Where it's very shallow, it's a delta, maybe 3 feet. All kinds of accumulated stuff from the stream bed coming down from a watershed that had agriculture. What you see bottom left is what Charles was describing a little while ago. As this wakeboard boat in surf mode produces a large displacement wave 200 or 300 feet away from that delta, the energy underneath is not seen until it strikes the bottom. It scrubs the bottom, and then the wave reemerges. This explains why people say, well, my wakeboard boat doesn't produce a wave any different than anybody else. It goes away at about 200 or 300 feet. Maybe. But the energy underneath the surface does not go away. And depending upon the topography of the lake, you get something equivalent to a tsunami wave, right? So as the water gets shallow, all that energy is pushing against the bottom and has nowhere to go. It pushes up. So the wave reemerges. And that's what you see in that image. That wave reemerged right near the delta. When it came in, it roiled up all the material. What the video shows is just like the University of Minnesota video that we showed you with all the stuff you couldn't even see with your hand after a while. I said you should think a little bit about what's in the lake bed sediments. Studies have established that these kinetic energy impacts from propeller downwash is capable of redistributing the bottom sediments, like I talked about when I flew over North Lake and saw this big plume. So that's bottom sediment being pushed somewhere else. It also causes release of nutrient concentrations. I spoke about that a little while ago. Phosphorus increases. The reintroduction of phosphorus and other bottom sediments into the water column is a concern for the development of toxic algal blooms in freshwater recreational lakes. Period. It just is. As the planet warms, ambient temperature goes up, it cooks that stuff near the surface. Pretty soon that becomes a toxic source. It stinks. It all kinds of bad things about it. Payette Lake in Idaho got interested in what was happening out there because of that risk. When I did the literature review for some of the write-ups in our studies, I got curious about, well, what's in the sediments in the lakes in Wisconsin? From 1920 to 1970, the primary agent to control aquatic plant growth in lakes in Wisconsin was something called arsenite. Arsenite is an arsenic derivative. Arsenic is a carcinogen. It's laying in some lakes in the lake beds. When you stir these things up, it gets into the water column. The phytoplankton absorb it. The fish eat the phytoplankton. We eat the fish. And we go a third arm, or whatever else is going to happen. It's not been studied yet. It's an area that should be studied. Again, as I said, only for the last 5 years have people started focusing on what's happening underneath the surface. So, in summary, there's impressive consistency in these studies that are being conducted, which demonstrates larger, faster, high-energy displacement wave risks across multiple areas that include surface safety threats to other vessels and lake users, nearshore disruptions, bottom scrubbing effects as we described, shoreline structure impacts, the release of nutrients from the lake bed, deep penetration propeller downwash subsurface. Again, we've demonstrated 25 foot plus. And then these wave attenuation distances need to be rethought and changed. Next slide. This is in what's going to be on the website, so these are all the references that we've used in this particular study. These, by the way, these references are selected based on the design of the studies being thoughtful, and you can pay attention to the data that's coming out of them. Next slide. So, the highlights of what we found on your lake are as follows. 51 minutes, not too bad. Okay, phase one. We saw high impact areas of damage noted to these DNR critical habitat designations. Study site selections were made accordingly. So we came out here in the wintertime, chopped a hole in the ice, used our submersible equipment and took photographs. And based on the local folks from the Lake Management District and from the Protect Beulah group, they said these are areas we've seen in fishing boats that we're concerned about, and it correlated. In phase two, where we did in-lake study, nearshore dockage and moored vessel impacts are revealed from 200 foot of distance from a wake boat in surf mode, minimal impacts from other comparative boats. That includes not only a ski boat, but the jet boat as well. Phase three, in-lake testing revealed that the wake boat surf mode nearshore impacts also had influence at 500 feet. Not as much, but some. You saw it. You saw the image. You saw the video. Next, please. Oh, we're already next. You're ahead of me. Thank you. So in phase one, when we looked at what's down there in the wintertime when you can see things, large aquatic plant loss areas. Specific plants that were taken away included coatail, broadleaf poundweed, cara. Those plants are favorable for fish. We're not marine biologists, so we invite you to talk to the marine biologist if you're going to go to court. But we know. Phase two, in-lake testing of lake bed impacts at 15 feet in both startups and controlled passes reveals surf mode wake boat operations do plant damage, sediment redeposition impacts, ski boats and other planing vessels. They just don't do that. They just don't do it. The energy doesn't get down that far. Period. Phase two, in-lake testing of the lake bed impacts at 21 feet. Again, startups, controlled passes, bottom plant movement, sediment disturbance. The other vessels don't do that. Phase three, in-lake testing of lake bed impacts at both 15 and 21 feet were replicated again And again, plant sediment disturbance with a more representative wakeboard boat, a more powerful engine. Comparable ski boats and other vessels don't have those impacts. Next slide. So what have we concluded? Wakeboat surf boat operations are producing lake bottom impacts in Lake Beulah, which are notable for disturbance in particular to aquatic plant habitat areas. Those impacts do not appear to be produced by water ski and other planing vessel operations under similar test conditions. The recent DNR plant survey data suggests that the sensitive area impacts to aquatic plants are considered favorable to game fish and lake water quality in Lake Beulah. We think if you want to add some bullets to your bandolier, you get a marine biologist to say absolutely. We found in our studies that the root structure of lake bed plants is different. Some lake bed aquatic plants don't have much of a root structure. They just sort of lay on the bottom. Others penetrate down and hold. The ones we're speaking about don't have much of a root structure, so they get ripped up. The DNR Critical Habitat Area Study has established that the areas being impacted by wakeboat surf boat operations are occurring, and they are adjacent to several of those designated critical habitat areas on your lake. Wakeboat surf boat operations, particularly propeller downwash, producing sediment disruption and redistribution impacts to the water column. The composition of those sediments in this study we did with you guys was not part of what we were asked to look at. But in other studies that we've done and other groups have done, there are some impacts based on what's in those sediments, particularly nutrient release. And you don't see that with planing vessels. Sizable population on your lake of home lake riparian owner wakeboats. 50 plus, I understand. But you also have a lake where they bring wakeboats in. So that aggregates the problem. Science informs public policy. We are happy to take questions, and Charles and I will do that together. I think you had your hand up first.